Hello. Continuing our work in area and volume, we're going to be looking at the area and volume of a cone. And for part of your work, you're going to be combining area and volume formulas from several different shapes. So we should be able to handle that. We know the formulas for different shapes, but for right now, we're going to look at the area and volume of cones. So if I have a look at my cone here, just like an upside down ice cream cone, I have a circle as my base, and I have the pointy bit is the curved part. So I have a curve going around here, and then my base is going to be the shape of a circle. Now the volume is given to us by a formula in our log table. It's a third pi r squared h, all multiplied together. The total surface area of the cone is going to be the surface area of the curved part, so the part that it would make up the ice cream cone, and then its base will be the area of a circle or a disc. So we add those two things together to get the total surface area of our shape. We'd have the curved area of our ice cream cone, and then we would have the area of our base, which would be the shape of a circle. So we use the formula we know for the area of a circle, pi r squared. The final thing that comes into cone type questions is I've put in the radius and the height of the cone in here, and you can see the curved the slant height, the angled height of our cone here is called the slant height, and it's labeled L, and you can see here that this forms a right angle triangle. And if I have a right angle triangle and I have the sides of a right angle triangle, I know I can use Pythagoras. So the side across from the right angle is L, my slant height. So this hypotenuse squared, the side across from my right angle squared, is equal to the other two sides squared and added together. And again, we already know this formula. We've used it loads of times, and it's just Pythagoras when we're relating the sides of a right angle triangle together, if we remember back to trigonometry. Now those are all of the formulas we need when we're purely dealing with a cone. So let's have a look at question 3, top of the next page, or top of page 259, and see what we can do. The given solid cone has a base radius of 5 centimeters and a slant height of 13 centimeters. So a radius of 5 centimeters and slant height is the name for our angled height here, the length of our ice cream cone part, which is going to be 13 centimeters. So we need to know that that is called the slanted height, or the slant height. Now, part 1, find the curved surface area, and we're told to give all of our answers in terms of pi. So I'm asked for a curved surface area of my cone, so I'm going to go to my log tables and I'm going to see that my curved surface area is going to be pi or L. So my curved surface area is going to be pi or L, and I know that r is equal to 5 centimeters, and I know that L is equal to 13 centimeters. And I want my answer in terms of pi, so I am not going to put the pi button into my calculator. I'm just going to multiply r by L. So I have pi multiplied by r is 5 and L is 13. So when I put that into my calculator, I get 65, and I put pi in here. So 65 multiplied by pi, because I had 5 by 13 by pi. So I get 65 pi, and I'm dealing with a surface area, which means it's centimeters squared for area. Now part 2. In part 2, we're asked for the total surface area. So this is our formula here. We're going to have the curved part, our ice cream cone part, and then we're going to have the area of the base of the cone. So for our total surface area, it's going to be our curved part plus the base. and I've written down that R is 5 and L is 13, and I want my answer in terms of pi. So I'm going to have pi multiplied by 5 multiplied by 13 plus pi multiplied by 5 squared. So I'm going to have 65 pi plus 25 pi. Again, I don't put the pi's into the calculator because I want them in my final answer. And when I add them up, I get 90 pi. And my units, again, I'm dealing with surface area, so area is centimeters squared. Part 3. We're asked for the height of the cone. So the name for the height of the cone is our h that we have here, and we aren't given it in the question, but it's our h that we have there. Now we can see when I label it in, I have a right angle triangle. This is my right angle triangle. And my hypotenuse is across from the right angle. It's going to be my slant height. So L squared is going to equal h squared plus R squared. And I know what L is. It's 13. Everything I sub in, I put in brackets, is equal to h, which is what I'm looking for, plus my radius is 5. So I get 169 is equal to h squared plus 25. I subtract 25 from both sides. And I get 144 is equal to h squared. To get h by itself, I need to get the square root of both sides. So I get the square root of both sides. And I've run out of space a little bit here, so h is going to be 12. And it's a length, so I'm going to have centimeters as my units. Part 4. So again, that was just using Pythagoras because in a cone we can see that we have a right angle triangle. Now part 4. The volume of the cone. So I'm going to write down my formula as I have for all of them. Third pi r squared h, and see what information I've got. I've got r is 5 and h I just found is 12. So v is equal to a third multiplied by pi multiplied by 5 squared, everything in brackets, multiplied by 12. And when I put that into my calculator, remembering that I don't put pi in, I get 100 multiplied by pi, and this is volume, so it's centimeters cubed. And that's my final answer. So we can see the different formulas that we need to know here. The only bit that it's a little bit different is that we're calling back to our earlier work in trigonometry, and we know with a right angle triangle we can use Pythagoras, and that's what we've got here. Everything else is following very much in the same style as what we've done in this chapter. We have formulas in our log tables, and we're going to use them when we see the appropriate shape. And those are the skills we need for right now.